Hey Geometry Kids, today we are going to look at 9.1 translations. Okay, now me and we're going to take one language and move it to another. We're going to talk about the transformation translation. Okay, transformation is when you change the shape, size, position, I should put or position of a figure. Okay. We have slides, rotations, flips, and dilations. Keep that in the back of your head. Anything too scary so far, so pretty much we're going to take this thing, we're going to move it over here, we're going to flip it, we're going to rotate it, we're going to make julienne fries out of it. Not that one. Alright, let's talk about isometries, guys. Oh no, I don't have that one over here. You have to add that in somewhere. I can't believe I don't have isometries. An isometry is a transformation where your image and pre-image, the two things, that keeps size and shape the same, but changes position. So you're just moving something on these guys. You aren't changing what it is. Okay. For example, look at this. We're always going to use pre-image and image. Pre-image is what you start with. The image is what it becomes, what you're mapping it onto. Okay. So the first one is this guy in isometry? And you're going to say no, because there's a change in size. They're bigger. They are not congruent figures. So that one, like I said, that's why that one's no. Okay. Now, for 1A, here's your pre-image, here's your image. Are these congruent figures? Yes. They are congruent. So we just changed where it is. Same as this guy. Your pre-image and image are congruent. They're just in a different spot now. So these are both yes, they are congruent. That makes my isometry. ISO equal. That's ready? No rapid fire. Just so you know this notation, if you have figure J, K, Q, and you transform it over here, K goes to K prime. I'm going to say K prime, that's what that little thing means. J goes to J prime. Q goes to Q prime. It's mapped onto it. Okay? It's going to come up a lot. Hopefully you guys aren't listening to music. You're actually listening to my lecture for this one. Okay. So in this diagram, NID is mapped onto SUP, S-U-P. What are the images of I and point D? Well, your image of I is because this is my pre-image, so I is getting mapped onto U. Draw an arrow. And D is being mapped onto P. Okay. What are the pairs of corresponding sides? This works the same way as similarity, guys. Now these are congruent. So NI got mapped onto SU. ID with UP going up, and SP with ND, or ND is getting mapped onto SP. Okay? Halfway there. We're going to talk about translations now. They're the first of our isometries. A translation is a fancy word for a slide. I'm not talking about the slides you stand at the top of. Yell "we" as you slide down. Okay? What a translation is you take a figure. Remember these vectors? Magnitude and direction. Each of these vectors is the same direction and the same length. And that's why A prime equals B prime equals C prime. None of them equal optimus prime. It's a joke. And I can change which direction those go in. Okay? Okay, let's try one. What are the images of the vertices A, B, C for translation of x plus 1, y minus 4, graph it in its image? Well, they already graphed A, B, C for me. And this point looks like it's negative 2, 2. This point's 1, 1. This point's 0, negative 1. Okay. So A to A prime, what you do is we're going to add 1 to the x. So that's going to become negative 1. We're going to subtract 4 from the y. So that becomes negative 2. Right? B to B prime, 1 plus 1 is 2. 1 minus 4 is negative 3. And C to C prime, 0 plus 1 is 1. Negative 1 minus 4 is negative 5. So A prime's at negative 1, negative 2. B prime's at 2, negative 3. And C prime's at 1, negative 1, 2, 3, 4, 5. There's my image. Pre-image, image. Now they want us to draw A prime, B prime, C prime. What do we know about all those three segments? They are congruent, because in a translation, all your vectors that take one point to the other are congruent. They're same direction and they are the same size. Okay? Okay. Now what rule lets us move P to P prime? Okay? Well, this coordinate for P is negative 3, 4, right? This coordinate for P prime would be 5, 2. And our rules can be x plus or minus something, y plus or minus something. How do I get from P to P prime? How far do I go to the right? What do I have to add to negative 3 to get to 5? I go over 1, 2, 3, 4, 5, 6, 7, 8. So I must be adding 8. Then what happens to my y? Well, that goes down. It goes down how many? 2. And there we go. That's my rule. Not too bad. A composition of transformations is a combination of it's a combination of two or more transformations. So we're combining some together, guys. And now I'm going to do something crazy. Are you ready? I want you to read this. Okay. Go ahead and take a second, read it. Ready yet? I want you to try this one on your own. I like it. It's a nice critical thinker. You have to take a try at to get your points for your notes. Doesn't have to be right, but make sure you take a stab at it. Enjoy.